Everyone. Welcome again to part two of this video where we continue our journey in exploring what are some of the types in Haskell and what are these ideas behind type classes. But before even getting into type classes, I think it's important that we spend a little bit of time today in understanding what are something called a type variable. And I did kind of touch upon the idea of a type variable in my very last video, where we looked at this anonymous function. And and uh, so this anonymous function over here is basically in pink. Let's do this. There you go. Okay, so let me just get my colors correct here. So I kind of looked at this idea that given this function, and if I were to ask Haskell, what's the type? Now, when I'm saying asking Haskell, what I really mean over here is I'm making use of the Haskell's type inference. Haskell has a type inference built into it, and which means that I do not have to statically, I do not have to kind of spell out the entire type for Haskell before even defining my function. I could if I wanted to do it, but I don't have to, and I can let Haskell infer. I can let the inference engine of Haskell's type system infer the type that might be associated with any value that I happen to create. Okay, so one of the values that I happened to create in my last video was actually this function. And when I asked Haskell what is this type associated with that with this function, what Haskell said back to me in this simple scenario is that the type associated with that value is something so again, just to be consistent with my colors here, is something of the kind where I pass in some type associated, in this case with my lowercase a, and outcomes some value that is associated with that same type a. And one of the constraints that were associated with this thing was that a is something that must actually be a number. Okay, so this was one of the constraints over here, that a must actually be a number, and this was the type associated with the specific value. So the discussion for this second video is basically understanding, is there a name, is there some kind of a name given to this lowercase a over here, and many people just like to call these as type variables. So these a's are basically nothing but just a variable. It's just a variable that happen to contain some type. Okay, so it's just a type variable. It's just a type variable, and and all it means from a very, very high level is it could be any type, as long as the type is associated with the with number type class. Now again, I do realize that we haven't yet even learned what type classes are, but just for the time being, the best way to interpret this specific type that is given out from Haskell is that this is a type variable, and I can have any type passed into this a as long as it happens to belong to an instance of the number type class, or in other words, it must just be a number. As long as a is a number, this is a valid type with this specific type, with this specific value. Okay, so given that idea, let's see if I can actually show this to you with some examples using our interactive Haskell shell here. So if I say, okay, give me the type associated with the function head. Now head is a inbuilt function in Haskell, and the type associated with the function head is that, let me just zoom in a little bit here. So one thing it tells me in this case is that head is a function that takes in as a first parameter something that's a list, but a list of anything, because there's no constraint associated with my type variable a. It could be a list of anything, and out comes back a value that is associated with this specific type variable a, meaning is okay. So all the method head tells you is that it takes in as an input. It takes in as an input a list of A's, and out comes back a value that is associated with my type variable A. Okay, so this is my input. This is my input that goes into my method head, and that's the value that comes out after calling the function head on that input. Okay, so again, I'm going to call this method head right now, and in this case, head happens. I'm going to use the prefix notation. So I'm just going to say head of let's say a list of A. So I'm going to say a list of numbers. Let's say, for example, list of numbers, and I get back the first element. I get back as an output the first element that is associated with this entire list. But note here that there is no constraint. There is no constraint that happens to be associated with my type variable a. It just means it could be anything. I'm just saying anything here, as opposed to my previous function, which I defined earlier in my first video, where I had let f of x equals to x plus 1. Here is really specific, where if I were to say what's a type on f, again, I'm still using this type variable a, but now I'm adding a constraint that a is that type that has implemented the number type class, meaning a must be a number. All right, so going back to my previous function call using the method on my function head. What if I were to change this from a list of numbers to, let's say, a list of characters? Would it still work? Let's try that. So if I'm going to just change these to a list of characters, it still works absolutely okay, because head just takes in a list of A's. That A could be anything, meaning I could even make it a function there. I could say, what if I pass in a method which in this case is a method that takes in two integers or two numbers, and then I have a method that takes in again two numbers there, and let's just have a list of these two methods here. So meaning this is basically a list of methods. Let's just get a type for this. So if I ask Haskell what's a type of this, what I get back over here is that I now have with me. So let's do this. Let's just do this a little bit slowly. So I'm asking Haskell what is a type that is associated with that value. What is a type associated with that value? The type that is associated with that value in red is this thing over here in green. What I have is a list of something. Now remember, in the first video, whenever we looked at this arrow, it tells you first thing, I'm dealing with something that happens to be a function. Okay, and in Haskell, functions are basically curried. Okay, and what curried in this case means is that every function Haskell takes in as a parameter one input value. So you can interpret this. As something. A list is basically a list of function that takes in because I'm going to just curry this. So is something of this kind, right? And the type of this value in red is basically a list of function, where this function that I'm dealing with is a function that happens to take in a single value a, and out comes back another function. That happens to take in one more value with some type a, and then finally get back the final answer. But now again, with these a's, is a constraint that that this a must be a number, and it makes sense because the functions that I have in this list, in this case, I have the plus method, and the plus method basically is a method that takes in two inputs and gives it back a value, and this is something that must be a number. So I'm dealing with something, some kind of a type where a must actually be a number. So one example to use this method plus, if I were to use this in an infix, sorry, in a prefix notation, I could have said plus 4 and 6, where 4 is my first parameter being passed into the plus method, 6 is my second parameter into the plus method, and the addition of 4 and 6 basically gives it back, gives it back 10 there, which is the final output there. Likewise, if I were to say plus of 4, if I take my function plus and I just pass in one parameter, the output of this is basically another function. It's another function that is still waiting to get back as one parameter. It's a function that can still take in one input parameter, and it's going to give you back something that is basically a number. Okay, so plus of 4 is basically, think of this plus of 4 as basically a method. It's a method that that takes in one parameter x, and out is going to be a value of basically 4 plus x. Okay, so plus of 4 is a method. It's a method. How do I know it's a method? Because I'm saying that it's basically a method, and that's my anonymous function declaration. It's a method that takes in a value that happens to be a number, and it's going to give you back. It's going to give you back basically the addition of 4 and x. Okay, so that's what plus 4 is, and I know it's getting a little bit messy with all my doodling and trying to show this to you on my Haskell shell here, but all we have done in this short video is basically played around with some of the types in Haskell, and explored the idea of what basically a type variable is. And let's just do one more example just before we close this. Let's just have one more example. So if I were to ask what is a type, let's say on a method that is snd, the type associated with the method snd is basically a function that happens to take in a tuple. It takes in a tuple, and the tuple could be of any kind. The first value in that tuple could be of any type. The second value in that tuple could be of any type as well. But you're going to get back as an output value the second component of my tuple by calling the method snd. So let's try that. If I say snd of on my tuple 1, 2, show a and b, the type of a and the type that is associated with the type variable b could be equal. That's fine, right? So I have a tuple of basically integers there, and I'm going to get back in this case the second parameter of my tuple. Likewise, if I change this, let's say, to an anonymous function. Okay, let's say I'm just going to pass in a function which is I don't know, let's just keep it something simple. Okay, what is this going to give you back? So let's have let f equals this thing. Let's have one more example here. So let's say if I were to call the method snd, and again, just to clarify, my method snd is something that takes in as an input a tuple, and it's going to give you back as an output the second component of my tuple. So if I say let f equals to snd of let's do this. Let's make it passing 1, and let's pass in a function there. Okay, so that's basically what my f is, and if I ask what is the type associated with that f, the type associated with that f is basically a function that takes in 2 parameters as an input, and out comes back some value that still happens to be a number. Now this makes sense because when I call snd on this entire tuple, what it does is it extracts the second component, which is in this blue over here, and makes f equal to the second component. So f is technically this method plus, right? F is basically referring to this method plus here, and because f is referring to this method plus here, it's just a label. It's just a label basically on this function plus here. So I'm just going to say now whatever this f is, if I ask what's the type associated on that f, is basically a function that takes in 2 numbers and out comes back a third number. Okay, so let's try that. So if I say f of 3 and 2, I should get back 5 because f is just a label on the method plus. Okay, so I should get back the addition of 3 and 2, in this case it's a 5.